Hello everyone, and welcome. Today, we're diving into the fascinating world of data analytics. We'll uncover what it is, how it works, and why it's so crucial in today's data-driven world. It's more than just numbers and graphs. It's a skill you use every day, often without even realizing it. At its core, analytics is about spotting patterns, identifying trends, and using those insights to inform and improve decision-making. For example, you check the weather forecast on your phone. You remember past chilly days, and based on that information, you decide to grab a jacket before heading out. That's simple analysis in action. You're using past data to inform a current decision. Businesses do the same thing, just on a bigger scale, with more data, and often with more complex tools. Imagine running a lemonade stand as a small business venture. You begin to notice sales consistently go up on hot days when the temperature rises. By tracking temperature and sales figures diligently, you can plot a graph, visually representing the relationship, and see a clear upward trend. This is data modeling in its simplest form, turning raw observations and data points into actionable insights that can drive your business forward. Trend analysis helps businesses prepare for busy seasons and anticipate customer demand, like coffee shops strategically stocking up on pumpkin spice and other fall flavors in autumn. The next step, building upon trend analysis, is forecasting. This involves using identified patterns and trends to predict the future and anticipate upcoming changes. Sometimes, forecasting can be as simple as applying a rule of thumb, like estimating you'll sell 2 more cups of lemonade for every degree increase in temperature above a certain point. Other times, particularly in larger organizations, businesses use sophisticated statistical models and algorithms for more precise forecasts. But the underlying goal is always the same, regardless of the complexity. It's to use yesterday's data, analyze current trends, and make smarter, more informed choices tomorrow. So, whether you're running a small lemonade stand in your neighborhood or you're part of a large multinational global company, understanding and applying analytics principles helps you stay ahead of the curve and gain a competitive advantage. And remember, it's not necessarily about diving into complex math equations right away. At its heart, it's about cultivating curiosity, developing keen observation skills, and paying close attention to the world around you. It starts with observing patterns and trends, meticulously recording the data you gather, and then visualizing that data in meaningful ways. Through this process, you can turn seemingly ordinary everyday events into powerful insights that drive effective decision-making. Because ultimately, analytics is everywhere we look, from the clothes you choose to wear each day to the complex strategic planning of multinational corporations. The journey into analytics starts with a simple question, a spark of curiosity. What patterns can I find in the data, and what can those patterns tell me? And with that foundational understanding in place, let's explore some of the powerful tools and techniques that make advanced analytics possible. Let's look at one of the most fundamental tools in the data science toolkit: simple linear regression. It's a cornerstone of predictive modeling, offering a straightforward way to understand relationships between variables. Imagine plotting lemonade sales against temperature on a graph. As the temperature rises, you'd expect sales to increase, right? Linear regression draws the best straight line, also known as the line of best fit, through those points, trying to minimize the distance between the line and each individual data point. This line gives you a formula, an equation that describes the relationship between temperature and sales. To predict sales for any temperature, plug in a temperature, and the formula estimates your lemonade sales. The slope shows how much sales change with each degree, indicating the sensitivity of sales to temperature fluctuations, and the intercept gives a baseline, representing the sales you might expect even at a very low temperature. But what if you want to predict a yes-no outcome, a binary result rather than a continuous number? Like whether a student passes an exam based on their study hours? That's where logistic regression comes in, a powerful tool for classification problems. It predicts the probability of an event, not a number, giving you a value between 0 and 1. Instead of a straight line, which wouldn't make sense for probabilities, logistic regression gives an S-shaped curve, also known as a sigmoid curve, showing how the chance of an event changes as your input variables change. It's perfect for questions with 2 possible answers, where you need to determine the likelihood of one outcome versus the other, like pass, fail on an exam, or click, no click on a website advertisement. Both methods turn messy data, raw and unstructured information, into clear, actionable predictions, providing valuable insights for decision-making. With these tools, you can predict numbers with linear regression or probabilities with confidence using logistic regression. empowering you to make informed choices. Real life is rarely simple. Many factors affect outcomes. Multiple regression lets you predict results using several variables like temperature, price, and advertising for lemonade sales. But which variables matter? Hypothesis testing helps you decide. Tests like the Wald test check if a variable's effect is significant or just noise. Model selection methods, forward selection, and backward elimination help you build a model that's accurate but not overly complex. The goal, a model that predicts well without overfitting. With careful testing and selection, you build robust models for real-world decisions. What if your outcome isn't a simple number, like predicting sales figures, or a straightforward yes/no decision? What if the data you're working with doesn't quite fit into those neat categories? That's where generalized linear models, or GLMs, come into play. They're designed to handle many different types of data, counts, like the number of website visits per day, probabilities, such as the likelihood of a customer clicking on an ad, and so much more. They offer a flexible framework for modeling a wide array of response variables. The secret weapon of GLMs is the link function, which cleverly connects your inputs, or predictors, to the appropriate kind of outcome, ensuring the model behaves correctly. For counts, like the number of cars passing through an intersection during rush hour, Poisson regression uses a log-link function. This ensures that the model only predicts positive values, which makes sense for counts. When dealing with skewed data, such as the cost of insurance claims, where a few very large claims can skew the data, gamma regression provides a much better fit than standard linear regression. GLMs allow you to leverage the power and logic of regression analysis for tackling a wide range of problems across various domains. The key to success is carefully matching the right model to the specific characteristics of your data type. With GLMs in your toolkit, you'll be equipped to analyze almost any real-world scenario you encounter. They're truly the Swiss Army knife of the analytics world, offering a versatile and powerful approach to data modeling. Sometimes relationships aren't straight lines or simple curves. Think of a plant's growth, fast at first, then slower. A curve, not a line. Non-linear regression fits these complex shapes directly to your data. It's used when science or theory suggests a specific curve, like drug decay in the bloodstream. Fitting these models is trickier. Computers use iterative methods to find the best fit. Algorithms like grid search or Newton-Raphson help find the right parameters efficiently. Non-linear regression lets you model real-world processes with accuracy. When the relationship is complex, these tools reveal the true pattern. They're essential for capturing the richness of real data. What if you don't know the relationship's shape at all? Non-parametric regression lets the data reveal the pattern without assuming a line or curve. Techniques like smoothing splines or kernel regression connect the dots to create a flexible fit. Semiparametric models blend structure and flexibility. Some variables are linear, others are freeform. This is useful when theory is weak or the relationship is unknown. These models help you discover hidden patterns that rigid models might miss. From simple lines to flexible curves, regression tools help us understand and predict the world. The right model turns data into insight, and insight into action.